So today we are going to discuss about the tricky questions for NET exams. So first of all, you have to consider this question. This is the question number 67, and in this question what you have to consider here is you have to consider the structure. So in the structure, basically in the structure we have the two hydroxyl groups, and if we have the two hydroxyl group in the structure, it means that the compound is diols. So the diols are not adjacent diols, but the two OH groups is present in the compound, and we have TBUCl. What does this means is we have tert butyl chloride in the presence of AlCl3. AlCl3 will act as a Lewis acid, and if this particular reagent acts as a Lewis acid, then there is a formation of the tertiary carbocation. We have already discussed this reaction in the carbocation. So we will get the tertiary carbocation, and this particular electron rich, and this is electron deficient. This particular reagent is electron deficient, and this is the electron rich reagent. So we have the reactant which is electron rich, and there is a mesomeric effect. Why I am saying so that there is a mesomeric effect? Because OH will shows the plus M effect. Because OH shows the plus M effect, that is the mesomeric effect. So OH donates its electron density in the ring, and there the ring is the electron rich, and this electron rich regions attacks the electron deficient center. So it means that there is the formation of the tert butyl substituents on the phenyl groups. So on the phenyl groups we have tert butyl. We all know that OH is the electron donating and electron donating group. Basically that is also para-directing group. So we all know that the OH group, basically we are talking about the OH group. So OH groups is electron donating group. So what we have to do is, like in the reactant, what you have to consider is the reactant is hindered reactant, basically because we have two OH groups and we have the 4 phenyl rings in the reactant. So OH is also para-directing group, but ortho group, if we got the results in the ortho substitution, then it's a very huge steric hindrance comes in the product. But if we are doing the substitution only on the para position, then we'll get the major product because of the less steric hindrance. Because if I'm saying if there is the tert butyl groups on the ortho positions like this particular compound, so this is very high steric hindrance is there. So very high steric hindrance is there, so we can't go for this particular reaction. So if we have OH groups are always also para-directing group, so the substitutions that will come on ortho and para position. But the ortho position is very sterically hindered. This is also sterically hindered. This is also sterically hindered. So this is meta will not happen. Ortho and para positions is always happen. So we have the major product, that is the second is the correct answer, because the para product is the major because of the less steric hindrance. Now come to this question. In this question we have given the Jablonski diagram in the initial stage in which the S0 to S2 transition is going to happen. So what you have to consider, this is the simple excitation. And this particular thing is intersystem crossing, because from one system to another system the electrons are going to transferring from S1 to T2. So intersystem crossing is happening from S1 to T2. The intersystem crossing is happening. So A is intersystem crossing. So according to the options you have to mark your answers. In T2 to T1, this is the fluorescence. Why I am saying this is the fluorescence? Because it's going from T2 to T1. So there is no change in the spin multiplicity. If the spin multiplicity is same, then that's the fluorescence. If the spin multiplicity changes, then that's the phosphorescence. Because from T2 to T1 the spin multiplicity changes. From T1 to S0 the spin multiplicity changes, that is from T1 to S0. If the spin multiplicity is changes, then that's the phosphorescence. So in the phosphorescence the spin multiplicity changes from T1 to S0, and in the fluorescence the spin multiplicity remains the same, that is from T2 to T1. So when the spin multiplicity is same, then the excitation is known as the fluorescence, and if the spin multiplicity changes, then the excitation is known as the phosphorescence. So according to that, our correct answer is A is intersystem crossing, and our B is fluorescence, and our C is phosphorescence. So the fourth option is the correct option. Now come to this question. It's a radical chemistry question and it's very very important in the exam because this is easy and little tricky, I can say. So in this particular question we have Br2 in the presence of light, so it's a photochemical cleavage of the dibromine. So basically if the dibromine is cleaving, so it's a homolytic cleavage leads to the formation of bromine radical. So we get the 2 bromine radical, and in this we are going to cleave from the tertiary carbon center, because tertiary free radical is the most stable, tertiary, secondary and primary. So that concept applies here. So we have to cleave from the tertiary carbon center, and there is a formation of H free radical as well. H and Br radical combine. This particular thing also combines and leads to the major product, that is the 3. There are another substituents also, but in the question it's mentioned we have to tell the major product. We don't have to tell the substituents, we have to tell the major product. So the main concept is that the tertiary free radical is more stable than secondary free radical and primary free radical. That's the main concept behind this question, and this small concept gives you the marks. So from 2 to 3 marks the rank is increased in the questions basically. So now consider this particular configuration. It's a very very simple question of stereochemistry. Like more the atomic number, more will be the priority. So 9 and 10, we have 2 centers. 9 and 10, both centers are chiral carbon. Both are the chiral carbon, or we can say the chiral center. So consider 9. Here consider the 9 centers. In the 9th center this is the chiral center. So with respect to this we have to tell either it's R or S. So we'll given the priority first because we have oxygen which is directly attached, then we have a carbon and carbon. So after that carbon we have oxygen, so this will get the second priority, and this will be have oxygen, then this gets the third priority and this gets the fourth priority. So from 1 to we are going to 3, so we will going to get the R configuration. Now next is this one, that's the 10th. So in this particular thing we have this particular chiral center, and this chiral center we have oxygen directly attached, so it will get the first priority, and we have 3 carbons, and this carbon is attached with oxygen, second priority. This carbon on this particular position connects with the oxygen, gets the third priority, and in this particular it gets the fourth priority because all the carbons are present in the chain. So from this particular center, that's the 10th center, 1, 2 and 3, we are going to get the S configuration. So our answer is 9R10S. So just by checking the configuration notes about the very small concepts, you are able to solve the questions in the exam. It's very important question this. So in this you have to tell which is the major product. So we have a base in the presence of the MeOH. So in the presence of alcohol we have a base, so it's 0.95 equivalents, so K positive and OH negative. So this particular OH that is present in the reactant attacks on this CO2Me. How we are going to write CO2Me? Like this, we have to like this. So if the OH attacks here, the OMe leaves from this particular position, and we are going to get the structure like isoelectronization reaction. So we have various isoelectronization reactions in the chemistry, in the name reactions and in reagents that we are going to study. But in this particular thing, what you have to consider is this particular OH when attacked on this particular OH, this particular OH when attacked on the CO2Me, OMe will leave. As the OMe will leave, there is a formation of a cyclic product like this. So it's a bridged compound. So when the base, that is the 0.95 equivalents of QH is present, then this OH minus attacked on this position, and if it's attacked on this position, so it's a hydrolysis reaction basically of that particular ester group which is present below the plate. So if the OH is present below the plate, then the hydrolysis of that ester group will happen which is present below the plate. So you can directly mark your answer. So you can directly mark your correct option in which the OH is present below the plane. So the hydrolysis of the below the plane ester will be happen. So that will be your final product. Thank you.